This week we are working with radicals. So we're going to start off with adding and subtracting radicals. Adding and subtracting radicals, um, in order to do that, you're just checking that the number underneath the square root, the radicand, that number is the same. You're going to need to do some manipulation on these problems. You're going to need to reduce radicals if you can. Um, so let's go ahead and give this example a shot. So it says negative 2 square root of 3 minus 4 square root of 28 plus 3 square root of 27. So we're just going to handle each of these radicals separately. So negative 2 square root of 3. Well, the 3 is a prime number. The only factors of 3 are 1 and 3. So we can't reduce that one. So this one's good to go. We don't need to reduce that one. So this one's done. So let's look at the next one. So it's negative 4 square root of 28. So can we reduce 28? So let's just think of two factors of 28. So I notice it's 28, 8 and 2 are both even, so this is an even number. So we can divide it by 2. So I'll use 2 and 14. But wait, 14 is also an even number, so we can divide it by 2. So this is 2 and 7. And now notice these are all prime. 2, 2, and 7 are all prime numbers. I can't reduce any of them any further. So we're going to rewrite this as negative 4 times the square root of, and let's use this factorization that we just came up with. 2 times 2 times 7. Notice I have a pair of 2's inside. Those 2's come outside of the radical. So this would be negative 4. We said we could pull out the 2, so times 2. And then what's left, what didn't we circle, was a 7. So this will be square root of 7. And then we can simplify this. Negative 4 times 2 is negative 8. And then square root of 7. So that takes care of this guy, this middle one. Now we go to the last term. I'll make this line a little bit longer. So 3 square root of 27. Okay, so let's see. Here's 27. Factors of 27, well, obviously it's not divisible by 2 because it's an odd number. So is it divisible by 3? 27 divided by 3 sure is. 3 times 9 gets you 27. Very good. So next, 3 is prime, so we can't split that up, but 9 isn't. 9, we could do 3 times 3. So we'll rewrite this. Oh, there's a whole bunch of 3's. This original 3 that's out front needs to make its way down. So this 3 is making its way down. And then these next 3 3's go underneath the radical, because this is how we're factoring 27. This will be 3 times 3 times 3. Okay? So next you're looking for pairs of 3. So, well, here's pairs of 3. We can pull that out of the radical. So we have the 3 out front. We're pulling out one of these 3's. And then what's left in here? Well, we didn't pull out one of the 3's, so this is going to be square root of 3. Next, 3 times 3, 9, square root of 3. Okay? So what we've done is we simplified each of these radicals. So this first radical couldn't be simplified any further, so we're just going to leave that as negative 2 square root of 3. This next radical, negative 4 square root of 28, reduces as, or simplifies to negative 8 square root of 7. Notice I kept the sign negative. So this was negative here, so I kept it negative there. And in my end result, it ended up being negative. So I'm going to write negative 8 square root of 7. And then here, my last one, 3 square root of 27, that simplifies as 9 square root of 3. So this will be plus 9 square root of 3. Okay? So next, the last part you need to do is you need to check to see that what's underneath the radical matches. And you can combine those, just like as if we had something like this, x plus 2x. Well, those are the similar terms because they both have x's, and we could call that 3x. But remember, what you couldn't do is if you had x plus 2, well, you can't add those because one has an x and the other one doesn't. It's the same exact idea here. So as long as what's underneath the radical is the same, so as long as what's with this coefficient is the same, then you can add them. So I got negative 2 square root of 3, and I have another square root of 3 right here. It's 9 square root of 3. So we can add those together. So 9 plus 2 is 7, square root of 3, and then minus 8 root of 7, like that. So this is your answer. Now notice we can't combine these because what's underneath the square root now doesn't match. I mean, there's a 7 out front of the square root of 3, but in order for us to combine them, the 7 would have had to be underneath the square root of 3. So this is as simplified as your answer is going to get. The next part of your assignment has to do with distributive property of radicals. When multiplying radicals, we're going to multiply, or using this distributive property with radicals, same thing, the numbers out front of the radical together. That's sort of like the first step, and then the second, we'll multiply the numbers inside the radical together. So in other words, if a number is out front, it needs to, if a number is not in the radical, it can't somehow find its way inside the radical. So let me work through this example with you to hopefully make that a little clearer. So here's 2 root 3 times root 6. And I'm going to write this out so that you can see it. So it says 2 root 3 times square root of 6. And then we're going to distribute 2 root 3 to the next term. So plus 2 root 3, put that in parentheses, times negative 4 root 5. Okay, so in this first group of parentheses, so these first two, 2 root 3 times root 6. So I have a 2 out front. This next radical doesn't have a 2 out front. It really has like what we would consider like a 1. So we could put a 1 there if we wanted to. So we'll multiply the numbers out front of the radical together. So 2 times 1. So that's your first step. Next, put your square root. And then step 2, multiply the numbers inside. So numbers inside will do 3 times 6. Bring down your plus sign. Same thing here. Multiply the numbers out front. So this time the numbers out front is 2 and negative 4. So we'll do 2 times negative 4. And then put your square root sign. 3 times 5. So the numbers inside, 3 and 5. 3 times 5. And then you just need to simplify. So 2 times 1 is 2. Square root of 3 times 6 is 18. Plus 2 times negative 4 is negative 8. So we can get rid of that plus sign. Because it's a plus negative, this is going to be negative. And then 3 times 5 is 15, square root of 15. So there'll be, so this is 2 square root of 18 minus 8 square root of 15. Next, you just want to simplify this a little bit. We can reduce 18 some. So we can reduce 18. 18 is divisible by 2. 2 times what is 18? 2 times 9. Can we split up 9? Sure we can. It's 3 times 3. So we need to bring this 2 that's out front down. Put your square root symbol, and then how did we reduce 18? As we reduced it as 2 times 3 times 3. And then do you have any pairs? Well, sure you do. You have 2s and 3s there. So we're going to pull that out. So we'll say 2 times 3, and then the square root of whatever's left. So square root of 2. 2 times 3 is 6, square root of 2. So I took care of this one. This next guy, 15, we could use, if we wanted to try to simplify it, we would use 3 and 5. Those are both primes, so this isn't going to reduce. So we're just going to leave it. So we'll just drop this all the way down. Minus 8 square root of 15. Oops. Terrible looking line, sorry. Minus 8 square root of 15. And this is as simplified as your answer is going to get. This was, so this example was multiplying square roots. If you need to go back and rewind to watch a part of it, please feel free to do so. But the key, sorry about this, but the key idea with multiplying square roots is whatever's on the outside gets multiplied together, and whatever's on the inside gets multiplied together. So those sort of the, if you want to call them the 2 steps to doing it, to distributing and multiplying radicals. You could sort of think of it that way. The last example I want to run through with you is on this video is dividing radicals. So like I said, if you need to rewind and rewatch this, feel free to do so. So here's dividing radicals, or you could call it rationalizing. It's either way. So in order to rationalize radicals or divide radicals, we need to get what our radicals out of the denominator. So the idea here is we want no radicals in the denominator. And like I said, we can call this dividing, not rationalizing. Even though that's technically what we're doing. So like I said in the previous two, you always want to start by reducing your radicals if it's possible. So let's try to reduce these radicals before we try to divide these two things out. So I got 2 root 7. So can we break up 7 into something, into 2 numbers? And the answer is no, because 7's prime. We could only split it up as 1 times 7. But that doesn't really help you any. 1 times 7 doesn't reduce what's underneath here. And 7 is not a perfect square. So, okay, we can't simplify the top, but let's see if we can simplify the bottom. So can we simplify the square root of 25? So let's see. Well, 25 is 5 times 5. So notice that's a pair of 5s right there. So our answer here is just 5. So the square root of 25 is 5. You probably noticed right away that that was a perfect square, and that's fine. So you wouldn't have needed to show this. So this is going to simplify as 2 square root of 7 over 5. Not very much work involved in this one, because the number that was in the bottom happened to be a square root, or I mean a perfect square. So if it happens to be a perfect square in the denominator, then you're in luck and you don't have much work to do. So this is how this one simplifies. Let me give you another example though, where what's in the bottom is not a perfect square. So let's take this example. 2 square root of 6 divided 3 square root of 2. For this example, we'll start this one off the same way that I told you to start the other ones off. See if you can reduce what's underneath the radical. So let's start with the numerator. Can we reduce 6? Well, let's see. 6, or square root of 6 rather, would be 3 times 2. That won't reduce. So the numerator is as reduced as it's going to get. Let's see the denominator, square root of 2. Hopefully you see square root of 2 is a prime number, so the denominator isn't going to be able to be reduced. So what we want to do next is we want to get rid of the square root that's in the denominator. So we're going to multiply this whole thing by just the square root part of the denominator. So the square root part of the denominator is the square root of 2. So we'll multiply by square root of 2 over square root of 2. So why did we do that? So the reason why we multiplied by the square root of 2 over square root of 2 is first is this is multiplying by 1, so it's not changing your problem at all. The second is that what happens when we multiply this bottom part out. And I'll show you that in just a second. So let's multiply on the top first. So remember your rules of multiplication. You multiply the stuff out front and the stuff inside. So we could put a 1 out front here if you'd like. And we'll multiply 2 times 1 together. And then we'll multiply the stuff inside. So we'll multiply the 6 and the 2. So this will be square root of 6 times 2. Okay. Next, this is all going to be divided by, we're going to multiply the denominators together. So again, we could see this as like a 1 in front of the square root of 2. So we would have 3 times 1. And then we'll multiply the 2's together. So 2 times 2. So this is square root of 2 times 2. Next, we're going to simplify this a little bit. 2 times 1 is 2. Square root of 6 times 2 is the square root of 12. Over 3 times 1 is 3. And notice square root of 2 times this, we have the square root of 2 times 2. Well, notice this is a pair of 2's, so it's going to come out of the radical. So this will be 3 times 2. So just tidying this up, we'd have 2 square root of 12 over 6. Square root of 12, can we reduce that? So 12 is 2 times 6, and 6 is 2 times 3. So we'll rewrite this as 2 times 2 times 3. Do you have any pairs? You sure do. The pair of 2's comes out. So this is going to be 2 times this. So 2 square root of 3. All divided by 6. Now, at this point, you're probably realizing that this is going to simplify further because 4 and 6 are both divisible by 2. So this is 2 root 3 over 3. So that's how you simplify those. I'll post another video in which I go over graphing and solving square roots.